Assalamualaikum and hi everyone. My name is Nashafina binti Muhammad Saha. My number matric is 10DDT 20TF 1046. On this slide, I will be discussing the design step for our splash screen or the application's opening screen. This is the very first thing a user sees when the application is being loaded. Our focus is on the XML layout file named activitysplash.xml. As we can see here, this is the design view we are using, which is mostly likely Android Studio. On the left side, we have the component tree and the palette window. These show all the elements we are using to construct this screen's layout, such as text view, image view, and the type of layout that contains them. The central part shows the visual preview of the splash screen we are creating. Here, we have already placed the app logo or icon and the application name by tagline My Student Notes application. On the right, we have the attribute window. This is we will set the detailed properties for each component, such as adjusting the font size, text, color, positions, margins, and constraints to ensure this element display correctly across different screen size. After saying how our splash screen was designed, we now move to the part that make it functional, which is the source code found in the file splash activity.java. The primary purpose of the code is to display the splash screen for a specific duration, for example 3 seconds. Let's break down some C lines of code within the onCreates method. Line 11, activity declaration. The code starts by declaring the class public class splash activity extend app compare activity. This is the activity where our splash screens run. Next, move to line 13, layout connection. Here we have set content view r.layout activity splash. This line connect this Java code to the visual XML layout we have discussed previously. Move to line 15 to 18, setting the delay time and the handle. This is the most important sections. We use handler.postDelay to create a time delay. The value delay time here, which is likely defined above 3000 milliseconds, determines how long the splash screen will stay visible. This gives the apps times to load resource or perform initialization. Next, move to line 20 to 22, navigations to the main screens. After the delay is finished, the code inside the runnable is executed. We create a new intent which acts the intentions to move from splash activity.this to main activity.class, the main screens of the apps. We then call start activity intent to launch the main screens. Finally, we call finish. This is critical as it closes the splash activity so the user cannot navigate back to the splash screen when pressing the back button. Moving forward from the splash screen, we arrive at a critical user interactions point, the login screen. This design is handled by the XML layout file named activitylogin.xml. This view displays the design layout for our user authentication interface. Our goal here is to create a clean and secure entry point for the user. In the center, we see the visual output of design. We have a form that typically include two main input files, one for username or email and one for password. On the left, the component tree shows the hierarchy of the UI elements, which is text view, edit text for input, and the main button are nested within the main layout structure, likely a constraint layout or linear layout. This structure ensures the elements stack and position correctly. On the right, the attribute panel is where we define the specific look and behavior of each component. For example, we set the hint text for the input fields, enter your email, and the background color Also, text color of the button. Last but not least, the layout constraint the center the login form effectively. After designing the visual login interface using XML, we now look at the source code that brings it into loginactivity.java. This Java file indicates what happened when a user enters credentials and presses the login button. Loginactivity.java is responsible for three core functions. First, retrieving user input, getting the value typed by the user from the username or email and password. Next, credential validations, checking if the input are valid, for example, correct email format, non-empty password, and comparing them against store user data either on a server or a local database. Last but not least, navigation. If authentication success, navigating the user to the main application screen. If it fails, display and validations error. At the start of the code, we must declare variable for the UI elements we need, such as edit text for the username and password and button for login. The onCreate method, inside onCreate, we connect this variable to the component ID in XML layout using findViewById. Next, login button listener. The most critical part is the code for the setOnClick listener on the login button. When the button is pressed, this function is called. Inside it, we set an input check, ensuring the input files are not empty. Authentication logic, calling a method to verify the credentials, making an API call to the server. Last but not least is response. If successful, executing an intent to the main activity, just like we saw with the splash screen. If unsuccessful, displaying a toast or snake bar with an error message like incorrect username or password. From the login screen, user may also choose to create a new profile. This brings us to the registration screen design, handled by the XML layout file name activityregister.xml. This view displays the user interface for creating a new account. The design here is to ask for necessary information of the user. In the center, we see the visual represents of the registration form. It is typically titled Create Account and will contain several input files, usually more than the login screen, such as full name, email address, password, and confirm password. The prominent Create Account button is to call to actions, guiding the user to complete the process. Hint text, providing a clear instruction for what data to enter into each file. We now here at source code for handling account creations located in registerActivity.java. The primary responsibility of registerActivity.java are first, data capture, to capture all the input such as name, email, password, and confirm password entered by the user in the XML layout. Next, input validation, to perform checks on the data locally before sending it into the server. This includes ensuring all requirements are not empty, verify the email format is correct, checking that the password meets complexity requirements, minimum length, and that the password and confirm password files is matched. Account creations API call, to the validate data, package it up, often in a JSON format, and send it into our back-end server via an API call the permanently create the user a new user record in the database. While the code detail is obscure, these are fundamental part present in registerActivity.java. Component initializations, setting up variable for all the edit text file, and the create account button. Next, button listener, the on-click listener attached to the registration button. This listener contains the main logic flow, which is data interactions, getting text from all the files. Validation logic, a series of if-else statements to check all validation rules. If password match into confirm password, show error message and return. Server communication, if all the local validation pass, executing the network request code using libraries to submit the data into the server. Response handling. If the server confirms success, the code will navigate the user either to the login screen or directly to the main application screen, and possibility save authentication token locally. If the server returns an error, email already exists. A user-friendly error message is displayed. After the user has successfully logged into a register, they are taken to the main hub of the application, the main menu. This screen is designed in the file activity main menu.xml. This screen represents the central navigation point, allowing user to access all primary features of the applications. In the center preview, we see a clean design. The screen features a header section likely displaying the app's logo or the username's profile summary indicated by the orange bar. Below the header, the key elements are the navigation buttons or modules. We see 4 distinct purple blocks. These blocks are likely designed to be easily tappable and visually represents the main functionalities such as add new nodes, view nodes, profile, and logout. The main layout is well organized, constraint layout or grid layout to manage the button effectively. We have reached the source code for main menu activity.java. The main menu activity.java file has 3 main responsibilities. First, initialization and data loading. To analyze the visual components, buttons, text view, and load dynamic content such as fittings, the username or profile picture from local storage or the server to display in the header. Navigations control to define the action trigger when the user tap any of the main menu buttons, directing them to the correct secondary screens. Next, state management. Managing the state of the activity, including handling the back button, preventing the user from accidentally logging out, and lifecycle events. In the onCreate method, we analyze all the button variables and link them to their respective ID in activity main menu.xml layout. Click listener on a separate set on click listener is applied to each main menu button. This is the core navigation logic for button 1, which is add new node. The click listener execute a new intent to launch the add node activity.java. For button 2, view nodes, it launch the view node activity.java. For button 3, profile, the click listener execute a new intent to launch the profile activity.java. For the last button is logout, it launch logout.java. Moving beyond to main navigations, this slide introduces a feature-specific screen, add new nodes interface. The design is handled by the layout file activity at node.xml. This screen is designed to be a focused environment where the user can quickly and efficiently input a new information into the application. The central preview shows a simple task-oriented form. The screen is titled Add a new node and features the necessary input files. First, we have title and subject, a single line input edit text for the node heading. Content file, a multi-line input edit text for the main body of the nodes. To the content, the clear call to call actions is the save or add button at the bottom, indicate a final actions. The component tree confirm the presence of these elements, typically 1 or 2 text view for label and the necessary edit text view for user input. The layout is likely a simple vertical structure to guide the user from the title to content. Hint text also provide a clear instruction text inside the field such as enter node title or write your content here. We are looking at source code from the file add.node-activity.java. The add.node-activity.java file executes the step for creating new content in our applications. Its primary function are data extractions to capture the text entered by the user in the title and content files. Next, validation to perform checks such as ensuring that the title or content are not left empty before attempting to the save. Data presentences. To take the validated data and save it permanently, either by writing it to a local database like SQLite or sending it to the remote server database via an API call. In the onCreate method, we analyze the edit text variable for the node's title and content and the variable for the save button. Button listener, a set on click listener is attached to the save button. This is where the saving process begins. Data retrieval. The code extracts the text from the title and content files and store them in a string variable. Validations logic. An if statement checks for required fields. If a field is empty, the code prevents saving and display a user-friendly error message such as please enter a title. Saving method call. If the data is valid, the code calls a methods save node to database. To handle the presenters layer. Navigations. After a successful save, the code typically is finish to close this activity and returns the user to the previous screen. We now look at the design edit node screen. This is handled by the XML layout file name activity edit nodes.xml. This screen is very similar to the add node screen, but its purpose is different. It allows the user to modify existing data rather than create a new data. The central preview shows a form designed for modification. The title is clearly labeled edit node and the interface contains the same two primary input files, the title file and the content file. The key difference is that when these screens load, this file will be pre-populated with the existing data of the node selected by the user. The screen features a primary actions button, likely labeled update or save change, and often the secondary button for delete. The attribute panel is used to ensure the edit text components are set up to receive the existing data which is happened programmatically in the Java code and are ready for user to edit. We ensure consistent styling with the rest of the application. This is the source code for edit node activity.java. The edit node activity.java file has a more complex set of responsibilities than the add node activity, mainly focusing on first data retrieval and display. When the activity starts, the code must first retrieve the unique ID of the node being edited and use that ID to fetch the current title and content from the database. It then displays this existing data in the edit text fields. Second, update logic. It handles the user tapping the update or save change button, capturing the modified text, validations the new content, and sending a request to the database to override the old record with a new data. Last but not least, deletions logic. It handles the event where the user chooses to permanently delete the node. The code will contain intent handling, code in onCreate to retrieve extra data from the launching intent like getIntent.getStrings node_id. This ID is vital for fetching the correct record. Next, database query. A method is called yearly in life cycle to query the database using the retrieve ID, and then set text is used on the edit text component to pre-fill the form. Next, update button listener. Attached to the update button, this listener extract the modified text, perform validations. Next, calls a database function like update node with node ID, new title, and new content. Last but not least is delete button listener. Attached to the delete action, this listener often includes a confirmations dialog to prevent accidental deletions. And if confirmed, calls the database function like delete node with the node ID.
Hi, good morning. My name is Nur Izzah Yasmin binti Muhammad Sofan. My metric number is 10-23L1027. Today I will present one of the core screens of our nodes application, the view nodes activity. This screen is where users interact with their saved notes, viewing, editing, and deleting. For activity_view_notes.xml file, this is the design blueprint for the screen. As you can see, the main feature is a list of notes. We use a recycle view to efficiently display a large number of notes. Each item in the list shows the note title placeholder and has associated edit and delete actions. The layout is simple, clean, and use a constraint layout to keep elements organized. Notice the empty state. There's an element like a text view or similar that will display the message, "You have no notes yet. Click Add now." This ensures a good user experience even when the list is empty. Now let's dive into ViewNotesActivity.java source code, which brings the design to life. This activity extends app compatibility, which is standard for an Android screen. Looking at the variable declaration on the left, we see the essential components: a recycle view to hold our notes, a text view called empty message to handle that no notes yet state we just discussed. Crucially, we initialize our helper classes, database helper for fetching and managing data, and node adapter to bridge the node data with the recycle view. In the onCreate method, which you can see on the right, we set up the recycle view with a linear layout manager to display nodes in a vertical list. The heart of this screen is the load nodes method. This is where the magic happens when the activity needs to display the data. Load nodes is responsible for fetching the list of nodes from our database using the dbhelper.getNodes method. If the checks the resulting list, if the node list is empty, it sets the recycle view to be invisible and the empty message to be visible. Otherwise, if nodes exist, it makes the recycle view visible and use the adapter.updateNodeList method to populate the list with data. This ensures the user always sees a clear status whether they have nodes or not. Finally, let's look at how the screen handles user interactions for editing and deleting a node, which are triggered by clicking buttons inside the recycle view items. We implement callback methods from our adapter on node delete and on node edit. On node delete is straightforward. When a node's delete button is pressed, it's called a method likely in the DB helper to remove the node and then calls load nodes to immediately refresh the list on the screen. On node edit handles navigating to the edit node activity. It creates an intent and carefully packages all the necessary information. The node's ID, title, content, and tag using intent.putExtra in the starts the edit node activity using start activity for result, expecting a result back when the edit screen is closed. Since we use start activity for result or for editing, we need the onActivityResult method to handle the response from the edit node activity. This method checks two things. One was the request code, the one we use for editing, edit node request code. Did the edit node activity return successfully? Result code result okay. If both conditions are met, it means a node was successfully modified or saved, and we call load nodes one last time. This ensures that the user sees the update title or content right away. In summary, the view nodes activity is robustly designed to display nodes efficiently using a recycle view, handle empty state gracefully, and manage the navigation flow for editing and the direct action for deleting nodes. Thank you. This is the activity_profile.xml layout file, which defines the user interface for the profile screen. It presents a simple layout for user profile management. The user's email is displayed read-only. There's an editable field for the user's name, ID, et_profile_name. The primary action button is the update name button, ID btn_update_profile, which trigger the update logic we will see next. This is the profile activity.java file responsible for handling the profile screen logic. We see the declaration of user interface element, text view, edit text button, and crucial helper classes, database helper, and session manager. In the overridden onCreate method, we set the layout using set content view layout activity underscore profile. We initialize the user interface component by linking them via find view by ID. We initialize the DB helper and session manager, retrieving the current user ID to identify the login user. The right side shows the data loading and update logic. Data loading load user details. This method fetches the user's detail using dbhelper.getUser details current user ID. If the database query returns a valid cursor, it extracts the name and email and set them on the user interface fields etnames.setText, dbemail.setText. Update logic, update name. The btn updates set on click listener triggers the update name method. If retrieve the new name from the text field. Validation, it checks if the new name is empty. If so, it displays an error and returns. After successful validation, the code proceeds to update the name in the database. The core action is calling dbhelper.update username, current user ID, new name, which returns the number of rows affected. Success condition, if row affected, a name update successfully toast in shown. The user is navigate back to the main activity using an intent and the current activity is closed with finish. Failure condition, otherwise a fail to update name toast is displayed. Now we move to the nodes feature, starting with the node adapter.java. This class bridges the node data node list with the recycle view to display the list of nodes. The adapter uses a node view holder pattern to manage individual node item views. It maintains a list of node model object node list, a DB helper, and an on-action listener interface. The on-action listener interface defines methods like onNodeDelete and onNodeEdit node model node, allowing the activity to react when a user interacts with node. The onBind view holder method is where the data is bound to the list item views. The node data, title, content, tag, date is extracted from the node model object and set on the respective text views. An on-click listener is set on btn delete. The node is removed from the database dbhelper.delete node. The node is removed from the local list node list.remove position. The user interface is updated using notify item remove. An on-click listener on btn edit simply calls listener.onNodeEdit node to trigger the edit screen workflow. Finally, we look at the node model.java class. This is a simple plain old Java object that structures the data for a single node. It contains the field ID, title, content, tag, date, and user ID. It provides necessary constructors for creating node object and getter methods like getTitle, getContent, and more for accessing its data. Let's conclude the code walkthrough covering the profile user interface and update logic, the structure of the node model, and the display of action logic within the node adapter. That's all from me. Thank you.
Assalamualaikum and a very good day to everyone. I'm Dalina binti Azmizam with my matrix number 10DDT 23F1032. So today I will be presenting our mini project. The title is My Student Node App, which we developed using Android Studio. We begin with the design phase. This slide displays the XML layout for node_item.xml. This file is the blueprint for how each individual node is shown in the list of the My Student Node app. Our design is minimalist and clean, using a card view to ensure every node is easily readable and visually separate for a good user experience. Next, we move into the source code, specifically looking at databasehelper.java. This class is responsible for data management in our My Student Note app. We are using SQLite for local storage, which means the notes are saved directly on the user's phone. As you can see on the screen, this code handles the creation of our database table, including table for both user login information and the notes content itself. It also contains the logic for fundamental database operation like creating, reading, updating, and deleting notes. This class ensures that all the user's notes and details are stored securely and reliably. Continuing with our database helper.java file, this section highlights the specific function that allow the My Student Note app to be fully functional. The code on the left shows the function for inserting a new user upon registration, ensuring the user login details are securely recorded into the database. The code on the right, specifically the Boolean functions, handles crucial validation. This checks if a username already exists and, more importantly, verifies the login credentials, the username and password before granting access to the main note-taking section of the app. These functions are the core logic behind the app's security and user management. So this is the final view of the database helper.java file. Illustrates the function required for managing the nodes themselves. Specifically, the code here implements the function for reading all the nodes so they can be displayed for the user, and the function for updating a node when a user makes an edit. Having all these functions for inserting user, validation, credential, and managing node data within the database helper class ensure the My Student Note app has a solid and reliable foundation for all its operation. Moving on, we have the session manager.java file. This is a very important class that handles the user login state using shared preferences. Essentially, this code ensures that once a user logs into the My Student Note app, the app will remember them. The function on the screen allow us to, the first one is create a login session after successful authentication. Next, check if the user is currently logged in, so they don't have to enter the credentials every time they open the app. And the last one is log the user out when they choose to end their session. This provides a smooth and persistent user experience for our application. Finally, let's look at the output and the user interface of the complete My Student Note app. On the far left, we see the login screen. This is the first point of entry where the database helper code we discussed validates the user credentials before granting access. In the center is the main screen or home dashboard of the app. This is where users can see their list of notes, and it serves as the navigation hub for all their saved student notes. On the right, we have the Add New Note screen. This simple and intuitive form allows users to quickly input a title and content for a new note, which is then saved using the database functions we implement. The overall design is user-friendly, making it easy for students to quickly manage and access their notes. Continuing with the output, these screens demonstrate the core management features of the My Student Note app. In the center, we see the main note list screen. This is where all the saved notes are displayed clearly. When a user clicks on an individually note item, they can view the full details or choose to edit it. On the right is the Edit Note screen. This screen utilizes the update functions we implement in the database helper class, allowing users to easily modify the title or content of an existing note and save their change. This feature ensures the My Student Note app is a fully functional tool for managing student information. We complete the note management cycle with the ability to delete notes. The screen on the right shows a simplified view for node interaction, and most importantly, the bottom of the screen indicates the option to delete a node. This uses the final delete function implement into our database helper, allowing user to remove any unwanted nodes quickly and permanently. Moving on to user management, this output screen shows the user profile and registration features of the My Student Note app. The center screenshot highlights the registration screen. This is where new user can create an account by entering details like their name, email, and password. This process is directly linked to the insert function we saw earlier in the database helper.java file. Once registered, the user is seamlessly directed back to the login screen or directly to the main application using the session management to track their login state. This ensures that only the registered user can access their personalized notes. Moving on to user management, this output screen shows the user profile and registration features of the My Student Note app. The center screenshot highlights the registration screen. This is where new user can create an account by entering details like their name, email, and password. This process is directly linked to the insert function we saw earlier in the database helper.java file. Once registered, the user is seamlessly directed back to the login screen or directly to the main application using the session management to track their login state. This ensures that only the registered user can access their personalized notes. As the final output, this slide confirms the successful connection and functionality of our online database system. Unlike the local storage, this demonstrates how our My Student Note app is configured to store user and node data remotely, like using MySQL. The tables displayed here confirm that the user registration, node creation, and update functions are successfully writing data to our hosted database, ensuring the application is fully robust and scalable. This concludes the presentation of our mini project, the My Student Note app. We successfully implement a complete mobile application covering the full cycle from design to robust online database management, a functional user interface. Thank you for your time and attention.